We've looked at how ionic compounds form in a previous video. We looked at sodium chloride, and we know that in ionic compounds, electrons are transferred from one atom, which is usually a metal, to another atom, which is a non-metal. Form two ions. There's attraction between a positive ion and negative ion, and that holds the ionic lattice together. Now, we can use this to predict the formulae of different ionic compounds. So let's look at lithium fluoride. Okay, so lithium fluoride. What is the formula of lithium fluoride going to be? So lithium, the electronic structure, atomic number 3, so it's going to be 2, 1. We know that's going to want to lose one electron, lose an electron, and forms a lithium ion here. And with the fluorine, atomic number 9, so that's going to be electronic structure of 2, 7. It's going to gain that electron from lithium. The cross has just gone in there, you can see it, to gain noble gas electronic configuration, which makes an F single minus ion. So you need one lithium for one fluorine, so the formula of that is simply LiF. Okay, so it's a bit like sodium chloride where there's one electron being transferred. Now let's look at another example here. Now we're going to have magnesium fluoride this time instead of lithium fluoride. Magnesium group 2, atomic number 12. So it's got an electronic structure of 2, 8, 2. It's going to want to lose 2 electrons, and it's going to form the 2 plus ion there. Now each fluorine is 2, 7, so each fluorine, the fluorine only wants to gain 1 electron, but the magnesium wants to give away 2. So there's a problem there. So you need 2 times as many fluorines for every however many magnesiums you've got. So the formula of magnesium fluoride is going to be Mg1, and for that is the one you don't write down, MgF2. That's magnesium fluoride, and that's because 2 electrons. The magnesium wants to lose 2 electrons, the fluorine only wants to gain 1. Okay, so another example here. This time we're going to look at magnesium oxide. All right, so magnesium 282, as we said before, it's going to want to lose 2 electrons to be like a noble gas from the 2 plus ion. Now, oxygen is atomic number 8, so that's going to be 2, 6. That wants to gain 2 electrons. You've got 1 there, 1 there. Now the magnesium wants to give away 2 electrons, so that's a perfect match. So there's 1 magnesium for every 1 oxygen. So the formula of magnesium oxide would just be MgO. Right, and then we'll look at one more. Lithium oxide this time. Okay, so lithium we've looked at before. It's 2, 1, and group 1 wants to lose 1 electron to form a single plus ion. Loses 1. Oxygen is atomic number 2, 6. That means it wants to gain 2 electrons. So the problem there, because lithium is only giving away 1, so you need 2 lots of lithium for every 1 lot of oxygen. So the formula of lithium oxide is Li2. That shows there's 2 lithiums, oxygen O. Lithium oxide. Okay, so you can predict the formula using that. And there's a bit of a quicker way of doing it rather than drawing dot cross diagrams every time. And so we just have a look down here. What we've got, we said that we know that here's group 1. They always want to lose 1 electron, so they form 1 plus ions. Group 2, let's take magnesium and calcium as their examples. They've got 2 electrons in their outer shell. They always want to lose 2, so they form a 2 plus ion. Group aluminium, which is the only metal we're worried about in group 3, it's got 3 in its outer shell. This forms a 3 plus ion. Now onto the non-metal groups. Group 6, well, they've got 6 electrons in that shell, so to get an 8 full outer shell, they need to gain 2, so they form a 2 minus every time. And group 7, 7 electrons, so they need to gain 1 electron, so that's just a 1 minus for the group 7, the halogens, fluorine, chlorine, bromine, and iodine. Now, the way I like to do this is, like, say, what is the formula of, let's say, aluminium fluoride? So I like to imagine a little seesaw, and to balance the seesaw you need the same number of pluses on one side, on this side, as the number of minuses on that. So aluminium, the ion that it forms is Al3+. Fluorine forms an F single minus ion. Now that's not balanced because we've got 3 pluses on this side and only 1 minus on that side. So the way we balance the seesaw is we need two more fluoride ions there. So the formula is going to be AlF3. Remember, in the formula you don't put any pluses or minuses. So that's a form of aluminium fluoride. Okay, let's do another example then. Rub that one out. Let's do potassium oxide. Okay, this time. Potassium oxide. So seesaw, we've got a K plus on that side, and we've got an O2 minus on that side. But too many minuses, not enough pluses, so we need another K plus there. So the formula of potassium oxide is K2O. Okay, let's do probably the most complicated example. Let's do aluminium oxide now. Okay, so there's our seesaw. We've got Al3+, that's aluminium, and we've got O2 minus on that side. Right, it's obviously too many pluses on, so let's put another O2 minus there. Now we've got too many minuses, we've got 4 minuses on this side, yeah? So we need another plus here, so let's put an Al3+. Now it's too heavy for positives because we've got 6 plus on this side and only 4 minus on that side. So what do we do? Put another oxide on there, and you end up with Al2O3 is the formula of aluminium oxide. Right, just before we finish this video, let's just do a slightly more complicated ionic compound. So we know that sometimes you have ions which have got more than one atom in them. So I'll do it in a different color. So let's think we have the nitrate ion, which is NO3 1 minus. So don't confuse the 3 with the minus up there. It means the nitrate ion is made up of 1 nitrogen. It's actually covalently bonded to 3 oxygens, but it's got an overall charge of 1 minus. So let's try and see what would be the formula of magnesium nitrate. So magnesium nitrate, do our seesaw. Positive ion, we've got Mg2 plus on this side, and we've got NO3 minus. Don't forget, it's not the 3 that's the minus, it's just the 1 minus up there. So we're heavy with too many pluses on that side, so we need another nitrate here. So we write the formula like this: MgNO3 2. But that obviously looks like 32, so we've got to put a bracket around the whole thing to show we've got 2 of them. So it's Mg brackets NO3 2. That's the formula of magnesium nitrate. And I can't stop myself, so I'll just do one more, the sulfate ion. Now the sulfate ion, don't confuse the 4 and the 2 there. The 4, it shows that's the number of oxygens, but the charge on this ion is 2 minus. It's the number, the superscript number. Okay, so let's do sodium sulfate as the very last one. Okay, sodium sulfate. Right, so we've got an Na plus there. We've got SO4 2 minus, and it's the 2 minus there, not the 4, that's the minus. So we're heavy on the negative side of the seesaw, so we need to put another positive sodium there. So the formula is going to be sodium sulfate is Na2SO4. Okay,